keep seeing this mistake on videos that I watch on YouTube, and I thought I'd do a video just dedicated to running a tool in for the first time, because this is where most of the crashes with machines are happen, is when the tool is coming down in rapid and it hits something instead of the workpiece, or it goes too far and it goes into the table or something like that, or a vise or a vise jaw or whatever's in the way instead of where it's supposed to go. And there's a very simple procedure to do on the control to prevent this from happening. And it's one of the first things I teach any machinist, because it's important for their own safety and the safety of the machine and the tooling and the workpiece, that that you're not damaging something or even hurting yourself if you're working in an open machine. And it's I guess it's something that you can work with CAM software and you can work with all this stuff, but to actually run the machine, this is very seldom shown in YouTube videos for some reason. And I think that any control, even the Mach 3, Mach 4, Tormach, and all these versions have these displays on the control to help you do this, but nobody actually shows how to do it. At least I've never seen a video, except my own video. I have actually shown this in previous videos, but I'm going to do it again because I think it's worth seeing again, and maybe people didn't see that previous video. So first, I've got this, let me show you over here. Let me move the camera and show you what I'm doing. Now I have a video on this part I've shown, so I'm not going to go over the machine work or doing this, and this customer is a little bit sensitive about that too. But I'm up to the point here on this block of aluminum to drill this big hole through the block. And so I got these long tools. And first of all, I'm going to show you something that I do, and it's a relatively simple thing, but when this tool here is too long for my tool setter, I can't go up there high enough to even measure the length of this tool. So what I normally do is I take my well, let me set this up so I can show you, because it's kind of hard to do it one-handed. First of all, I get something. I have this old woodworking square that my grandfather had or something. I think that's where I got it from. And this is good enough for what I'm doing here. I measure the length of this blade from the squares, and it's around 7.432 is, I don't know if you can see that. And I actually wrote it on here with a Sharpie so I can remember that. So that's the first thing to do. Anything will work. You can have a combination square and set the scale from the blade, from the blade area, the amount on the scale, and you could do it the same way. You wouldn't even need to measure it with the calipers for this, because it's kind of close enough for touching off a tool like this. This is a big drill, and I don't know if I can show it to you this far away. If you can see it. Let me try it and see. I think you can see the little screen of this. This tool setter has like an optical comparator like thing, and when you get the lines lined up, you read the digital readout over there. But what I do is I stick this thing on the tool like this, kind of square to something, with this part hitting the tip of the tool in this case. Okay, let's see if this works. I kind of stuck the camera on the tool, so it's going to rotate with the tool here on the tool setter. But I stick this blade on here so that it comes up against the drill. Get it angled a little bit better so you can see it. See, so it's hitting the tip of the drill up here, and I can see it in the screen until I bring it into focus here. I got to rotate well, maybe I can rotate the blade a little bit here, the square. Okay, so it's pretty much in focus right there. And then I line this is kind of hard to do it with the camera in my way, but trying here. Okay, and then I move the Z-axis of this thing until I get it lined up with the crosshairs on this. I mean, this could work on a digital one maybe, but it'd be a little bit trickier because they kind of like to run with a computer program. This manual tool setter works really good for this. See, so now I'm lined up to the end of the square with the crosshairs, and then I'm going to add this distance of 7.432 to my number here of 13.454 plus 7.432. All right, so we're going to go over here and we're going to just, I mean, I could do this on the control, but I'll just do it right here, which the number was 13.454. 13.454 plus this number right here, 7.432 equals, so 20.886. That's close enough for this drill. So then I'm going to come over here to my control, and I'm going to go to the see what tool's in the spindle, because it just changed tools to this tool. It's offset 48, so I'm going to type in 48 here, and my number was, what was it again? Can't remember that long ago. 20.886. So 20.886, and that's going to enter that number when I push input into this 48 offset. So 20.886. Okay, now I got to lift up this heavy tool and stick it in the spindle of the machine somehow or another. So let me see if I can do that. Really isn't like a one-handed affair here to do this. Let me move you over here, maybe you could see. I've got to unclamp the spindle, get in here, and stick it in, and clamp the spindle. All right, now we set our offset on tool number 48, 20.886. And we put our tool in the spindle. Now, the program is setting right here. I've got a bunch of these MOOs because I can't change this tool in the changer. So I have to be sure and put it in there and take it out when it's done. But what I really want to show you here is, and particularly with a long tool like this, you see how close it is to the work and everything? So I'm going to set my rapid down, 25%, put the machine back into memory, and I'm going to push start here and watch what happens here. Oh, I got a bunch of MOOs here. Okay, here we go. All right, now I see I could put it into single block right now, but I'm not going to yet. I'm going to let it start coming down in Z. Okay, it started to move in Z. I pushed feed hold right here. Put it into single block. I don't want it to go any more than this one movement on the machine, but right now I'm going to look at the display, the distance to go display. This is important. This is what you got to do to prevent these kind of crashes that people have. It says 5.337 inches. It's going to go. So you could eyeball that. You could say, okay, I'm looking at it and I'm saying it'd probably be all right. Sorry for the camera because I'm trying to do many things. I'm going to take a tape measure. Oh, it says 5.33. We're going to look at this. We're going to look at this and we're going to say, okay, it's still got 6.5 inches from the tip of that tool, more or less. I'm not measuring it exact with this scale. I don't know if you can see that, before it hits that part. So we can make that move and not hit anything. Okay, this is important. And I have it in single block. So I'm going to push cycle start right here and let it make the move, because it's not going to hit anything. Now, I'm going to go back to my display and see where the machine thinks it is. Right now it says it's at 1 inch above the part. And I can take something that's 1 inch tall, like this. Now I have 10 thousandths left on this face for a finish cut, so it won't go under there, but it'll be close. So this 1-inch block, if this was a finished face, should just barely slide under that tool, but it won't right now because there's 10 thousandths left on this face. But it looks okay, and the drilling cycle is starting 30 thousandths. Well, you can't see it. Let me get up in the program a little bit. And the drilling cycle is starting 30 thousandths above Z0, so that'll be okay. And we could let that tool run. See, this is important. See, I don't know why nobody shows this stuff, but this is important to show how you actually run the machine. You know, they show all this programming stuff and everything, and all this CAD and CAM and everything, but you know, this does you no good. I'm going to check something else here, just for the heck of it, to see if I'm roughly where I'm supposed to be here. You know, I do this stuff sometimes just to kind of verify things, but it's good. I already probed the part and everything, so I'm sure of that anyway. But they don't show how to actually run things. This to me is more important than, you can do all this fancy programming you want, but if you don't know how to run this tool in for the first time, this is where you have accidents. Now you can have an accident in the middle of a tool, it rapids into something like that, but the simulation in the CAM software, in the CAM software will usually show you that, a collision in the middle of tool path. But it doesn't know what's going to happen at the start because it doesn't set the machine up, and you're doing that. So this is important. So now I can pretty much let this run, and we can start to drill this hole here. And see, it didn't run into anything. It's the first time I set the offset of the tool and everything. I didn't use any kind of touch probe to set the offset. I mean, that's probably safer, but even if I have a machine that has all of that stuff on it, I still do this when I run the tool in for the first time. I can't overemphasize this to you. I've seen this accident so many times. Somebody just rapids right into the part, into the stock, into the vise, into the table, like I saw in the YouTube video just today. And just this one little simple thing of looking at your distance to go display will keep this from happening if you just do just what I showed right now in this video.